questions below, and I'll respond quickly or in the next episode of Louis Yam. Hey everyone, how are we doing? The audio sounds good. Can we get an audio? It doesn't sound muffled or anything. For some reason, should I get Petros today? Ooh, Petros, some good chili. Good to see you there, Cameron. Good to see you there, Aaron. Good to see you there, Jennifer. Does the audio sound good? Audio bueno. Me gusta audio mucho. I don't know what it is. Let me hear. I don't know if you can hear this. I don't know what it is with my headphones or something. Still sure about that? I want to hear this on my computer. I'm gonna go over here and hear this. I think it sounds muffled. I think it sounds worse than usual. I might get Chipotle like that. Sounds good. I don't know what it is with my headphones then. Maybe I need to reconnect my things. Okay, let me go. I want to hear it because I'm like, if it sounds crummy, I don't want to. Here we go. Let me hear. You're gonna hear myself. Oh, it sounds fine. Sounds fine. Oh, I was wrong. I don't know what it is. Things sound muffled in my ears, but what's wrong with my headphones? Good to see you there, Catherine. Good to see everybody. You see the problem is there. Pixel. I'm a Google fan. Oh, okay. Got some Pixel buds right there. I didn't even know that's what they're called. Well, the test was last night. Let me load up the Discord. So I want to copy an image over here from what I posted to Discord and talk about it just a little bit here. I'm gonna chill mood today, or chill the hard couch chill. I'm gonna chill vid today. Nice, like that right there. I want people to look at this report right here. Let's go over to it. Low key. Oh, Hibachi Factory is some good stuff. I do agree with that. I like some Hibachi Factory. Still on the strip, right? Pretty good stuff. Hibachi Factory. That's some good cheap hibachi. Then there's a new place in the fort. Is it Sumo or something? What is it called? There's a new place in the fort. Check them out. Really good, fresh hibachi. Kind of more like a restaurant-style hibachi, so it costs a little more. But I'm just knocking over all my Pokemon. I got little Pokemon over here that are 3D printed, and I'm just knocking them off everywhere, so you can barely see them. With that said, I want you to understand this connecting letters report, which is something we don't do in 201, but we're going to learn from it real quick. So with this connecting letters report, what it means is the level is the amount of start early bonus someone has. Does everyone see this? So the level is the amount of start early bonus people have, literally on the yellow highlighter. Now it does it. So that is the amount of start early bonus. This is the mean for that group. Now it is not 100% consistent. It is not 100% consistent, as in this group right here, which is people who have 10 start early bonus, don't have the second highest grade. But just grab from the top and look at the top 4 groups and look at, I would go top 5 right there, because that one, I don't know. Now I'm choosing what I want to see, and look at the bottom. There's a little bit of overlap right here with these, but can you see some pretty big difference? You've got you got 50s and low 60s-ish, and high-ish or mid-high 70s, or mid-high 60s and low mid 60s. Oh my gosh, low 70s, mid 60s. So if you were to look at this, the people who are doing some sort of starting early, we're seeing between like 65 to 75, somewhere, just a quick round on that. And down here, we're seeing 52 to 66 or so, 67, you can round it. Yeah. No, a few people have their grades, so a few people got them, but yeah. And if you look, there's a pretty big divide right here. If we just do the average of these, it's somewhere between about 7 or 8 points. Now, that doesn't mean if you start early, you will make a great grade, but I want to point to this group right here. They are the standout group. They are well above, and just look at the drastic difference between not starting early and starting early, but we can't say, like, if you start early, you'll make good grades. But if you're watching this right now, the connecting letters means that Group A is its own thing. So Group A might be these individuals right here. Group E is its own thing. So literally we think that these individuals are all part of one group. So sorry but that's like they are all part of one group, but then they could share membership across this. Like that group could be there, but that's the E group. But that individual could be a member of the C, D, or E group, where the people who only have one are definitely the E group. But you might say, why is this one with an even lower average in the E or D group? It's probably due to small sample sizes and larger intervals because of smaller sample sizes. All of this to say, we'll probably do some work here in a moment. What should you be doing? I should know in a few days, because we generally try to get them graded pretty quickly. I was grading a lot last night. I was literally from 3, I was even doing it during office hours, asked people to swing by office hours. During office hours, I was grading a ton. And the answer is, as Cameron said right there, start early. I was grading and I was answering emails. Some people took the test early, so I was grading. I pretty much was grading everyone. If you took the test early, it's graded, because I kept up with grading until the test started, and then I wasn't able to keep up because I was responding to emails if anything occurred. Thank you to everyone who emailed me if there's any issues. But the biggest thing to know right here is the hardest part about this class is going to be the what's. What is the hardest part about this class? Like if you had to say, I'm probably going to lose points on my grade when I do the what? I wouldn't say my Pearson. The exams. The exams on my Pearson can be tough too. The exams are where we probably lose points. Like the exams are, you get one shot, and however you do on the exam, you do. So if you don't do well on the exam, it's not the end of the world, but that's your one shot. And then, you know, you have to have other grades to usually counterbalance that. Now, if you do good on the exam, if you make A's on the exam, it gives you a bunch of wiggle room. And so then you want to, where do you want to spend your wiggle room? On the assignments, or where do you want to get your wiggle room saved up for? You save up all your wiggle room in the semester. Some people call it building a cushion. People told me that. They build the cushion for the what? Where do you build your cushion? For the what? Like where you have all your, like, I can do poorly on that. It doesn't really matter for the final. So I do that for the final, exactly. You don't want to be like, I'm doing so well on the test, so I don't have to do the homework. Has anyone ever said that, like, I'm trying to do really good on tests, so I don't have to do homework for this class? I mean, you could, and then you just need to ace the final also. But a lot of times people say, I'm doing everything I can, so that way when it comes to the final, there's no stress. Because it's like, well, who's ever had that class? I had one class where I needed to make like a 20 on a multiple choice final. I had like 103 going into the final. The final was worth like 20% of my grade. I had to make like a 20 on the final to get an A. It was something, maybe I had like 104, whatever it was, because about the math, what it would be, and it was like 20% of the grade. So I was like, oh, if I make a 20 on this multiple choice test, I was like, I should just answer a few questions and leave. And I was like, oh, I'll answer them all. But, and I think I made a 98 on it. So how much of an impact do you think, me and Calc right now, exactly, and that's a good feeling, right? How much of an impact do you think the start early bonus will have, assuming you get them all? I'll look at it as the final little push. So, you know, what I never do is if you have an A minus, you can only get an A. Well, that's the highest. If you have a B plus, you can only get an A minus. So what I do is the people, you want to be able to get every advantage you can. And I'm willing to be more flexible. It really depends on how much start early bonus you have. So I usually only do up to 2 points, but let's say someone did every little thing I asked them to and they made an 85 in the class. So if you did every little thing I asked you to, you did start early bonus, you did Discord bonus, you're doing everything, you put in notes on, you're doing everything, and you make an 85, I could see giving you a what? Remember, you only get up to the next level. If you have an 85, I could see giving you a what? I could see giving you a what? You'd have YouTube bonus, you did everything. If you make an 85, I could see giving you, not a 90, a B plus. Not a 90 though, a B plus. A B plus is an 88. So it's all these little things that get you to the next grade level, because it goes 82 to 88 is a B. So if you were like at an 85, or, you know, if you're at like, maybe you're a student who's this is not your thing and you make like a 74 in the class, but you did everything, and I look and I'm like, they did the start early, they did the Discord, and you have a 74. But this is the thing, if you're watching this now and you're like, man, I want my 74C to be a C+, that won't happen if you haven't been doing the things. So if you're doing the things right now and you're worried, know that you can kind of get to the next grade level if you're doing everything. I can't promise you have a 72, I'll bump you to the C+. But the people, I have to show some sort of metric where someone's like, oh, I got a 75 and I got a C+, and someone's like, I got a 77 and I got a C. Why would the person who got a 77 get a C? I tend to practice a lot for Calc 1 and Calc 2. Nice. And we'll start some of the... Why would the person who got a 77 not make a C+? I'd definitely give them just a regular old C if they what. And I don't look at names when I do this. I just sort the columns by what they have. If you don't do any extra credit, you don't come to class, you don't do the start early bonuses, you do nothing, then if you make a 77, you make a 77. And here's the thing. Who do you think a company would want to hire? The person who goes the extra mile or the person who just does the thing to get the grade? Who would the company be more interested in? The 75 who's like, I'm going to do everything I can. I'm going to show up. I'm going to start early on assignments. I'm going to be diligent. They're going to want the extra mile right there. So to me, it's like, well, of course I'll give this 75 a C+. I mean, C to C+, not that big of a change, but still, it helps. I mean, everyone wants that. If you can get a plus, a B instead of a B plus or B plus, the person who goes the extra mile, exactly. It goes to the office, exactly. And it doesn't have to be like you're doing, and here's the thing, is it's not like I'm asking you to really do extra work. With the start early bonus, is that really extra work? Is the start early bonus extra work? Is the start early bonus really extra work? And then we're going to pull up some chapter sampling proportion. No, it's not early. I mean, it's just doing your work early. Just being like, you know, I think it's best if you do the work early, and if you get stuck, you ask questions. So I think it's good. Is going to class where you get bonus really extra work? No, it's just going to class. And so I'm not going to take all points if you don't come to class, but I'll give you a bonus if you come to class. So what I'm asking you to do, and a job should never be like you have to do extra work to make your grade, but here's the thing. I'm here to grade your statistics knowledge, right? So if somebody doesn't want to do any bonus, all they need to make an A in the class is what? I'm here to grade your stats knowledge. And if someone wants to make an A and they don't want to do any bonus, they don't want to do their work early, they don't want to show up to class, they don't want to do Discord notes or anything like that, all they have to have is what to make an A in my class. I'm like, well, if you want to make an A, all you need is this. All you need is what? What do you need if you don't want to do any bonus? Stats knowledge. That's what you need. If you have stats knowledge, you make an A, because that's what I'm grading you on. But I think other metrics are important too, and that's where it's bonus. That's where it's not really part of the actual stats grade or your stats knowledge. So your grade is really your stats knowledge, but then the bonus is, well, what are you doing that would make you desirable to companies and would have people want to hire you? And, you know, I'm trying to foster these things and encourage them. That's where the bonus comes into play, and that's the world. Okay, so who wants to do, how about we knock out the homework? You think we can get the whole thing done? Who would love to do the whole entire homework right now? We get the whole homework done. Every bit of it. Proportion intervals. Possibly. Only possibly. Me. Right there. Let's do it. Okay. So the homework, the whole homework. 1453, chapter 13. We go back to chapter 13. Confidence intervals. Homework. Here we go with the first question. Pew Research in 2018 pulled a random sample of 1,058 adults or teens. What is the first thing we do? You know it. Leo knows it always. What is the first thing we do when we get to a question like this? What should we do when we get to a question like this? What should we do when we get to a question like this? Notation. Notation, brother.
Notation, brother.
So here we are. Tell me any of the notation right now. A lot of new notation right here. Start me out with any of it. It'll help us for many of the problems. Sample size equals this, which is probably less than 10% of the population. And then this right here of the sample, so that's p hat. If p hat equals 0.45, what else do I know? Here's a hint. If p hat equals 0.45, what else do I know? Close, William, that is p hat because it came from a sample. Good answer is William. Let's throw William some points. That is p hat, though, because it came from a sample. And then the other one is going to be what? Because I found the other value right there related to it. So what's the other one? It's not p hat, it's q hat, which is 1 minus p hat. It's the complement of p hat. This is the lower, and this is the upper for the interval. And let me ask you this. So it's that to that, and this is the confidence level. So that's the confidence level of the interval. With this right here, we're going to go get some steak dinners tonight. Well, the steak dinner is going to cost between $30 through $50. And we have questions on the test just like this, not with steak dinners though. What is the estimate of how much the steak dinner will be? What is the estimate? Like I say, yeah, $30 to $50 for the steak dinner tonight. You're thinking it's probably going to be about how much? What do you think is the estimate of the steak dinner price? What is the estimate of the steak dinner price? 30 to 50. It'll be $30 to $50. What is the estimate? Well, here's a hint. The estimate is at there you go, Cameron, right there, 40. Because 40 is at the center of the interval, just like 45 is at the center of this interval. Yeah, 40, like 40. And then you would say 40 plus or minus how many dollars? 40 plus or minus how many dollars to make the interval? So I estimate about 40, 10, because that's the margin of error for the interval. Now, whenever we do intervals, the intervals themselves will look the following way. An interval will always have an estimate at the center. It'll have an upper, it'll have a lower, and the margin of error is always what the length of the interval. There's the estimate right there, which is the center of the interval. The margin of error is always what the length of the interval. Sarah, good to see you here. So it's estimate plus or minus. Not the same. Look at the length of the interval. Hint, this is the length of the interval. So the margin of error, which are the blue things, I didn't think it would go back up there. The margin of error, which are the blue things, really? I don't even know what's happening. The margin of error, which are the blue things, are half the length of the interval. Because how big is my interval 30 through 50? How big is the interval 30 through 50? 30 through 50 is how big of an interval? Yeah, that's where you want to be like, oh, the margin of error is half the length of the interval. It's 20, 40 plus or minus 10. How big is the interval 42 to 48? How big is the interval 42 to 48? 42, great job, margin of error, exactly, is 6. So the margin of error is 45 plus or minus, and then the margin of error is the after part. 45 is the estimate, which comes from the sample. So the margin of error would be what? 45 plus or minus, because we could re-express this interval as 45 plus or minus, like take this right here, and 45 plus or minus 3. Yep, and that's the margin of error. So the margin of error is half the length of the interval. You can do the formula. If you want to do formulas, which are fine, you can do upper minus lower divided by 2, because that is, when it does that, upper minus lower divided by 2 is half the length of the interval, and that is equal to the margin of error. The upper plus the center divided by 2 is equal to the center. I think I said center, that's upper minus lower, because that's the average of the two ends of the interval. Like 30 plus 50 is 80. Divide that by 2 and you get 40. So you can kind of see some of the formulas we were doing. Oh, because the cursor's up there, so I keep zooming back out to that. So let's look at the questions right here and see what theory we're covering for this. Interpret the interval in context. So here's what you need to know for the next test. Does anyone remember for our test this time, we had I am blank % confident that the true blank, that's this next test. Does anyone remember for our previous test, we had blank % of the variation, so it's like, yeah, exactly. And so, do you remember the R-squared interpretation? On the final, I believe there's 4 interpretations. I'll double check. But who got to the test last night and went straight to the interpretations and aced them? Did anyone go to the interpretations and like ace the interpretations right away? Just like you're like, interpretations, I got this. Guess what the strategy is for the final? Great job, Jennifer, William, Cameron, Aaron, and Sarah right there. Guess what the strategy is for the final? On the final, there'll also be interpretations. Well, I'm pretty sure I can check. I'll check at the end of class or the end of office hours. On the final, there's also going to be interpretations. So we're going to do it again. Here we go.
Wow.
Is that our another one? That's Owen Wilson.
Another one.
Another one? Might have been. Might not save that to soundboard. I got to hear it. Wow. Wow. So here's the interpretation. I am blank % confident that the true blank is contained in the interval blank to blank. Should you read what my Pearson tells you and start by reading the My Pearson answers. To prepare for the test, code 393. To prepare for the test, oh, MuteBot's not on. No wonder the points didn't get given out. To prepare for the test, should you read what My Pearson tells you and then pick from the My Pearson statements first? To prepare for the test and to be well prepared, I know we're waking up MuteBot here. Should you read what My Pearson tells you? To prepare for the test, I need my Red Bull. To prepare for the test, should you read what My Pearson tells you first? The answer is no. If you want to prepare for the test, start by doing what with any time it says interpret the interval. To prepare for the test, and if you do this every time, you're going to get good at it. How should you prepare for the test? MuteBot's awake. Trust Brian. You should write it down first. Sarah, perfect answer. Let's throw out some big points for this. Sarah's right, right there. Exact answer. So Sarah is right there. Oh, MuteBot's here. Oh, you're here, MuteBot. You're there in the chat. So MuteBot is awake now, wondering where he's at. Thank you, MuteBot. So he's doing well right there. There we go. Drink some. I didn't forget you, MuteBot. I'm sorry. He says, I am MuteBot. Oh, did Cameron say I am MuteBot? Because that's what he says when you say MuteBot. So Cameron said that. I might have had the exclamation that tricked him. Yeah, he didn't react to the. He didn't react because of the exclamation mark. I'll say that. Okay, so let's read. Okay, I got to write one more thing here, and then I got to get serious. I got my Red Bull now. Okay. When you do this interpretation, you need to put confidence level here. There's the confidence level, and then you'll either write mean, difference in means, minus, or proportions. And then afterwards, you need context. And this is the lower, this is the upper. With 4 parts to this interval, what part do you think people have the most trouble with? With 4 parts to this interval, William is MuteBot now. Everybody's MuteBot. We're all MuteBots. So the second part is where people have trouble. And let's think about this. We are trying to estimate, and see if you can do it in the chat. It'll show you understand how to use this on the screen right here. That says mean, difference in means, proportions. Then you have to add the context to any of them. This is the percent confident you are. That's the lower. That's the upper. And let's go back and look at this here. And we are trying to estimate what? Online several times a day. The true what? Don't even read their interpretations. We are trying to estimate what? If you look, it says 95% confidence was made. There's the lower, there's the upper. There's part 1, there's part 2, there's part 3. So really, can anyone write this right here? We're estimating the true proportion. Bingo, true proportion of what? Sarah, you're exactly right. Can you write the full thing? It's 95, 4.42, and 4.8, 48. So what's going to be the full sentence? If this was on the test, what would you write? If you try writing it out now, you'll get practice. So it was, and so write the full thing, William. You got it. William, you're on the right track. Keep going. This is the practice. We're getting ready for test 3 right now. Remember, don't look at what My Pearson has. Think about how it's going to look on the test. So if you can write this out in the chat, I'll throw some 10,000 points. First person gets it. Other people just try practicing it. Don't worry if other people have already written it. Remember, the more you do it, you get to the test. It's easy peasy. So I am. And so the values were 95. The other one is 42 and 48. You can do it as a decimal, 0.42, 0.48, or 42 and 48%. So I am. What do we have right here? Someone write up real soon, I think. I am. Sometimes people say we are. I never like the we are, or one can be. I am. 95% confident. Oh, it's a really close, Sarah. I'm going to throw you the 10,000 points. But notice, you have true proportion. You need after this, and good work, you need after this the context. So we'll try again here. So keep going. This is why I do this right here, just to make sure we have it. You have true proportion, but after that, we need the context still. I am 95% confident the true proportion of teens that went online several times a week is contained in the interval. Boom, William right there. That's exactly right. And that would be worth all 4 points. And if the grader took off points, I wouldn't be happy with them. So great job, Sarah and William right there. Really good practice. Now we look at their interpretations. One is 95% confident that if we were to ask all teens whether they go online several times a day between this and this, would say they do, because all teens is the what proportion? All teens is the what proportion? So one can be 95% confident if you were to ask all teens, which would find the true proportion, because that's for all. You wouldn't. We're not doing it for the sample. We want to know the true proportion, which would be for all teens. So you have to look at their interpretations and think how it applies to yours. Like I'm saying, I'm 95% confident the truth, which would be for all. So that's where you have to kind of use what you have and then look at their differences. Explain the meaning of 95% confidence. This is an interesting one. It goes to the theory of 95% confidence. It's not that we're confident in one interval. It's about the repeated process of making intervals. So here's a phrase. 95% of 95% confidence intervals will contain the truth 95% of the time. And basically, for 10,000 points, it's not about one interval. It's about making repeated intervals. So we're talking about what? That in the long run frequency, 95% of 95% confidence intervals will contain the truth. So we're talking about the what? This graphic right here. What is this? That in the long run, repeated viewing of 95% confidence intervals, the law of large numbers. It's not about one interval containing the truth. Great job right there, Cameron and William. It's about the long run frequency of observing or looking at 95% confidence intervals. So that's what they're going to say with their answer related to that. If one were to collect many random samples of teens, about 95% of the confidence intervals one construct would contain the true proportion of teens, I think, or about the sample size doesn't really matter. I'm looking between these two. Look at answer A. Look at answer A. Answer A is wrong. Why is answer A wrong? It's got a bad word in it. Look at the second line of answer A. Answer A is wrong. Very wrong. They throw in that one word. I'm glad they did it because that true sample proportion. Yeah, because the truth is not from the sample. The truth is from the population. So we would never say true sample proportion. We're trying to estimate the true population proportion. So that what two letters should go together? Not SP, but it should be either what or what. So true sample proportion should be, yeah, and that's population parameter, and that's the parameter we're interested in. Kind of applies to this, but we're talking about the truth, so that'd be the population sample. The truth is for the population, so that could be population sample. Doesn't make sense. It's not really this P. It's that the truth is for the population. So right here, this would say population sample, and that's wrong. Let me not click that. Really good question. A lot of good theory. Want to point out because that is tricky. Here we are with question number 2. And so homework question 1. And so knowing the theory is the important parts. Remember that, because then you can figure out a lot of questions. Chapter 13, confidence intervals. Homework 2. Here we go. Reaching out 2 standard errors on either side of the sample proportion makes us blank % confident. Ooh, I think people should know this. Don't click the answer. You should think. And the answer is technically not this value, but kind of close. 68, 95, 99.7 works the same way for confidence intervals. It's actually 95.449, I believe. So they're not going to put that answer, but 95 is going to be the answer. We'll see that when we make some confidence intervals. So 68, and look, they do 68, 95, 99.7. I wish they put the 0.7 on there, but yep, they're saying, hey, remember that 68, 95, 99.7, the empirical rule. So the margin of error right here, we need to learn some formulas. That was an easy one that we just did right there. We are going to learn some formulas. Man, we did that question in less than a minute. What are we doing? Okay. I think we'll be easily able to finish this homework. Have people who've been coming to office hours, I'll try to mention this during class, have you been getting most of your homework and quizzes done-ish during office hours? Have you been able to get a lot done and you don't really have a lot of my Pearson outside of our meeting time here? Like you come to this or you watch it a little bit later if you miss it, and then that's what I'd hope. Kind of my goal. And then hopefully if you follow along, you review, you do the extra stuff, get the homeworks done here, so that frees up, I mean, just 2 hours a week here, you get your homeworks done, and then maybe you find some extra video help on the others, and then you're good to go and you get your MyPearson done. So not that much work outside of class, I'd hope, on the MyPearson if we do this here. And there's less and less as the semester goes. Like first start a lot of Pearson. So we need to know an equation. The equation we need to know. Yeah, awesome, Jennifer. Well, good work. That's how to really learn them. That's how to really learn the material. Here is the equation we need to know. I'm going to take a moment because we have to learn it, and we'll learn it today in class. P times Q over N squared root. This time they got hats. I want to go right there. So this formula has to it 3 parts. How many parts are to this formula? How many parts? How many parts are there in the confidence interval formula? How many parts are there in the confidence interval formula? Three parts. Great job. What I'm doing right now, I'm writing the remaining confidence interval formulas for the rest of the semester. All of these confidence interval formulas for the rest of the semester have, finish my sentence, all of these confidence interval formulas for the rest of the semester have in them what? Here's some hints. Telling me my points. All of the confidence interval formulas for the remainder of the semester have in them we don't highlight that. All of the confidence interval formulas for the remainder of the semester have what? What do they have? This one has 3 parts. Scary letters. They all have 3 parts. So if you understand how the confidence interval works today, every other interval for the remainder of the semester is built from the same 3 components. Does that make sense? It's like, I mean, if you understand how a Nissan works, would you kind of understand how a Ford works, how a Honda works? So you'd be like, well, yeah, I mean, I know how a Nissan works. So, I mean, there might be some differences, but the same basic components go into a Honda as does a Nissan. So we got some Hondas, we got some Nissans, we got some Toyotas. Don't buy the Toyota. I'm getting Toyota. Buy Nissan. Or, yeah, I don't know what I got. Yeah, Nissan. So right here, let's look at the first equation. Fiat, fix it again, Tony. Oh, yeah. Oh, my gosh. So with this right here, the very first thing on the screen right here, what is this in notation? What is that in notation? Just what is that? Like, I mean, it's p hat, but I mean, what is p hat? So p hat is what? What is p hat? How do we find it? The sample proportion. So it's found by the formula. So it's found by x over n. Does that make sense? Because if I said I talked to 30 of my friends and 10 of them own a dog, what do I find? Explain to me. I talked to 30 of my friends and 10 of them own a dog. So what have I found there? What does that mean? I talked to 30 of my friends, 10 of them own a dog. X is 10 successes. 30 is who I spoke to. I found the sample proportion of people who own a dog from my friends, right? So that's what p hat is. It's the sample proportion. The z-score, boom, right there, have doggos. The z-score is going to relate to the what rule? 68, 95, 99.7. And the bigger the z, the more area we cover, and the more, think of a C word, the interval. So 68 is 1 standard error. 95 is 2 standard errors. The more confident, you'll cover more, the more confident you are. So the Z controls how confident we are. The P is the estimate of the truth, the PI, excuse me. P is the truth, P hat is the estimate of the truth. And then this quantity over here is known as the standard error of P hat, right? No, standard error of P hat, that's what it is. Standard error of P hat, which is a metric of uncertainty. Now, think of this. When would we be more certain? With a bigger or smaller sample size? When would we be more certain or have less uncertainty? Like if you collect a large sample or a smaller sample, you'd have less uncertainty. Collecting a what sample would give you less uncertainty? A larger sample. If you take more data, then you'd be like, I collected more data, and we're dividing by n, so when you divide by n there, and guess what, in the last formula, you'll be shocked to know,
Wow.
divide by n. In all these formulas, you divide by n, meaning if you have a larger sample, you have less uncertainty. The standard error is a metric of uncertainty, kind of like a what? It's not quite this, but the standard error, which is not this, it's kind of like this. What standard error almost sounds like another thing that's just a metric of variation, which would spread data out. Standard error sounds a lot like what? Everything in blue is a standard error in the darker blue. Standard error sounds a lot like standard deviation. Standard. Can I make that a quote? I don't know. That's it's funny, William. Let me throw you some points for that. Standard deviation. William's like, I got this. I got those answers. 10,000 points, William, right there. And so these are the three components. So think about this. We have an estimate, and then after the estimate comes a what? Everything over here is a margin of error. Because the margin of error, say this again, no worries, William. The margin of error is everything in the equation after the what or what. The margin of error in the equation is everything after the what or what. The margin of error in these equations is those second and third components, which is everything after the what or what. The plus or minus. So the margin of error. So in the first interval, we're trying to estimate the true proportion. What is your best guess of the true proportion? So remember, we're trying to estimate the true proportion. So we're trying to estimate P over here. What would be your best guess of the truth? What would be your best guess of the truth? We'll put it maybe above it. Your best guess of the truth would be what? Your best guess of the truth would be what? If you had to guess the true proportion, you'd probably guess the what as a guess. Think of your estimate. If you had to guess the true proportion, the best guess of the true proportion, like if you want to know what % of your friends really own dogs, and if you've got like thousands of friends, your best guess would be the proportion from your sample, P hat. So what do you think Y bar is trying to estimate? The sample mean's probably trying to estimate what? The sample mean is probably trying to estimate the what? Like the sample proportion tries to estimate the true proportion. So the sample mean's probably trying to estimate the what? What would the sample mean try to estimate? Which mean though? Which mean? Mu, the true mean. Great job, mu. We're trying to estimate the true mean. So what do you think the sample difference is trying to estimate? Sample difference tries to estimate, put one word before it. Sample difference tries to estimate, and this is what we're trying to estimate right here. So maybe we'll highlight that with color coding. This is the estimate of this. This is the estimate of this. The true difference, yeah. So the sample tries to estimate the difference in between the true means. What is the true difference between these means? So imagine you and your friends are running miles. Would you use the top, middle, or bottom interval to figure out who's faster? Like who has a faster time on average? Would you use the top, middle, or bottom one? If your friend and you are running which equation would you run to see who's better on average? The top, middle, or the bottom one would be the equation to use. Not the middle, good guess. Not the middle. That would be just for you running a mile because that's on average for one. It'd be the bottom one because it's the difference between two averages. Like what's the difference between your time and their time? To estimate the true difference between you two, because that's the true difference between two means, because then you have an average, they have an average, and you want to figure out the true difference between you and them. Now, if only you are running miles, you'd use the top, middle, or bottom to just figure out your average mile time. Your average mile time. Like, how fast do I run on average? What is my mean mile time? So maybe I've got mile times. I'm trying to figure out my mean mile time. Just for me, I'd use which one? The middle one. Now, if I wanted to figure out what percent of my friends truly own dogs, and I've got like 5,000 Facebook friends, and I talk to 200 of them, and I want to figure out of all my friends who might own animals, what percent truly own dogs, which one would I use? Because I could talk to my friends, find out from my sample how many own dogs, and then the top one, right? Do you notice? It depends if we're doing categorical data, quantitative data with two groups. Categorical up top, quantitative with two groups. That's how you know which one you're doing. So we're gonna have cat and quant come back right here. Pause. Oh, when we get to the conditions. This is the last thing I'll say on this, but what do you think condition 1 is for all of these intervals? For every single one of these intervals, condition 1 is what? For every single one of those intervals, condition 1 is random. For every single one of these intervals, condition 2 is what? For every single one of those intervals on the screen, condition 2 is what? For every single one of, oh, I like that camera right there. For every single one of those intervals, condition 2 is 10%. And then you pause, just pause in the chat, and you figure out if you're doing proportions, which is categorical, means, which is quantitative, 2 means is the second one. So that's literally the top, the middle, and then this, because this is the order in which we do it. These are both quantitative. Chi-squared is categorical, more on that when we get to it. And then you pause, and you either do success failure, or you do now what is called nearly normal. The 2 means has 2 independent means as the condition. And right there are all the conditions. Everyone see this. Here's all the conditions for the remainder of the semester. How important is it to know the first 2 that we practice all the time when we say random, 10%? So the whole remainder of the semester, when I ask you conditions, that's everything. Whole remainder of the semester, every condition. So then you need to know when you get to the third condition, what kind of data are we dealing with? We'll talk more why it's called nearly normal, no longer large enough n. Independent means that one mean does not influence another. They're independent of each other. Count data means they're both categorical. Expected cell count greater than 5 is kind of like success failure, where we have at least expected cell counts for 5 for every expected cell. And cat or quant is going to be huge. And look up there at the very top, cat, quant, and that's technically quant cat because the x is categorical in this, but it's the t-tests are for a quantitative y, and then chi-squared is 2 categorical variables, which creates count data. Count data is just when you have it in cells for a contingency table. That's a lot. That is huge right there, so know your stuff. Margin of error right here. So to do this, I probably can figure it out really quickly, and I'll show you the math. Because all I'm doing is using those equations that I know, that I've done a lot, and doing what right here? I think we're on the wrong track. What is Brian doing? And I'll show you the math for this right after I do it. Just taking the numbers and whatting them. 99%. Plug them in. I've used these equations a lot, so let's show how we did this right here and plug them into the equation. So the numbers were, and the numbers aren't so important, I'm going to round them probably just to make them nicer. So make sure to not round them like I'm about to do. We're using this top equation right here. We'll write it just by itself. I literally lost my pen. There it is. Literally. For a second, lost it. So the equation was p hat plus or minus z star. Put a star on it. That means we pick it based on confidence level. P hat times q hat over n. I'm going to round this just for niceness. P hat is 25%. What is q hat now? You have to find this sometimes on problems. P hat is 25%. What is q hat? I'm rounding my numbers from the problem just so I don't have to go back to it. P hat is this. Q hat is what? What's Q hat? 75, boom. 1 minus, it's complement. Now, it said n was equal to 1,997. Well, it said it only wanted the margin of error. So since it only wants the margin of error, we only have to find everything after the what or what. Because the problem says, what is the margin of error? So I don't have to solve the whole thing. I only have to solve everything after the what or what. It said find the margin of error. I only have to find everything after the what or what. Plus or minus, exactly. I only have to solve everything after the plus or minus. Now, if you notice, I'm missing a what right now. I have all these answers here. I have p hat, I have q hat, I have n. I'm missing a what? Missing the what for this? I'm missing. What am I missing? All night. What am I missing? I am missing the what for this equation? The z-score. The z-score is based on the percent confidence. When we make an interval, it's going to be the area between, and then we can go here and plug in the p, nope, I want to go right here, and put in, it was a 99% confidence interval, and it's 2.5758. And there's the z-score right there, which I've done this a lot, so I kind of knew that if you look back at the calculator, it's 2.5758. But think logically. The z-score must be between these numbers because 68, 95, 99.7. So logically speaking, the z-score has to be between what and what. When you go 68, 95, 99.7, the z-score would have to be between what and what as you go out like this. Logically speaking, z-score would have to be between what and what? 68, 95, 99.7. So your z-score would have to be between, because you go through 99 when you go from 95 to 99.7, the z-score would have to be between what? 68, 95, getting closer, 99.7, we've gone too far. 2 and 3, exactly. So you could, if I said an 80% confidence interval would have to have a z-score between what and what, an 80% confidence interval would have to have a z-score between what and what. This is good things to know, but 80% would have to have a z-score between what and what. Because 68, 95, so 1 and 2. So it's 1.6449, I think. 1.6449. Oh, wait a minute. That's a 90%. There we go. 1.2816 is the other one. Oh, 1.2816. Yeah, 1.6449, 1.95996. So many numbers rattling around in my head. It's closer to a 68 when you do the 80% confidence interval. Okay. All we do is plug in the numbers. If you literally just take the z-score here of, who thinks they follow this, that if you just take the z-score of 2.5758, because that's the 99% z-score, just plug in your numbers right here. So what I do is I do p, oops, how do we lose that quick? P times q, there's the top p hat times q hat, over n, square root of the quantity, and then times 2.5758. And even rounding this problem, we still got 0.025, and we would have got it right even with the rounding I did of the numbers. Does that make sense? Are people following? So that's how you get the margin of error right there, plugging in the numbers. Usually people get stuck on the z, which is based on the normal curve. That's usually where people are like, I have no idea how to get that z-score. And this is... We've just done about 90% of today's lecture. Maybe we've done almost 99%. I'm 99% confident, but that is, if you've been here today for this, you know a lot of today's lecture. Explain what the margin of error means. It's a plus or minus. It's around the estimate. So we had an estimate of, what is it, who are on the wrong track? Wrong track thinks 75%, plus or minus 2.5%. So one is 95% confident the observed proportion is within 2.5% of the population proportion. The probability that any given adult surveyed, no, it's not a singular adult. Yeah, this is weird, the way they're phrasing it. One is 99% confident that the observed proportion of adults that responded, which would be the sample. So if they're saying observed, the observed is in the sample, so within this of the truth. So that makes sense because we wouldn't say the sample is within this of the sample. Because what we observe, the observed proportion is p hat. So we're trying to use p hat to estimate the truth. And yeah, just the phrasing's a little bit weird. I don't know if I'd phrase it that way. We'll see here if we got some multiple choices that we can just like do really quickly. What is the 95% confidence interval? So if you know the formulas, if you've watched today and you know the formulas, I'm going to do speed running questions. How many can I do? So are people okay if Brian tries to speed run everything and maybe... So you'll see how to do them, and I'll show you what I'm thinking, but we have all the theory right now. Does anyone here want to see me speed run or maybe do one or two slowly? If like I'll look at what the majority says since we have enough here, so I can just look at it. Speed run as quick as possible so you can see them all as quick as I can do them, or do one or two slowly. Your call. You're here. You get to choose. So yeah, is that yes to speed run? I like speed running stuff, but you can say, Brian, please slow down. Please do them slowly. I got that rebel energy. Speed run. Well, it's been voted speed run. Right now in the calculator, I've typed in p hat. So if you look at what I have right there, thank you right there, Ethan and Jennifer. P hat, 1 minus p hat, no. 1 minus p hat is q hat. P hat times q hat over n square root. That's the margin of, excuse me, that's the standard error. P hat times q hat over n square root is the standard error. 95% confidence interval has a z-score of 1.96. That's the margin of error. So now we simply take the p hat right here and go add the margin of error. So that's, it wants to percent 4.91, right? 4.91. Now we can logically deduce that that's about 1.3 higher, right? 1.3 higher, 0.13 higher. So if that's 0.13 higher, this should be 4.65, and that should be right. Nope, didn't error. 0.0487 minus. Oh, no way, really? Okay, well, now we really made mistakes. This is what happens when we speedrun stuff. Let's try it again, see what error we made. Looks about right. Okay, that's p hat. That's q hat. P hat times q hat over there. That's p hat times q hat over n square root. 95% confidence interval times 1.96. That's the margin of error. Times, sure, let's times it by 100. There's that. And now 4.718, which is that as a percent. What? Rounded 2 decimals. 100,000 points, what's the problem? And I'm reversing this number. 100,000 points, what's the problem? I'm keeping my answers. What's the problem, though? Like, that's right. How do we usually report an interval? How do we usually report an interval? Intervals are usually reported with the what and then the what. I don't have it on the screen, I don't think. We usually report the lower, they're backwards, yep. They are backwards. We usually do the lower and the upper. So my first answer was 4.65 right there. It might get mad at me because that might round the other way. 4.91, I think it's going to give it to me within the margin of error, and it is correct. Given this right here, the proposed true rate is in the, let's look at it here, 5% is not in the interval. So since it's not in the interval, it's not really plausible because the interval does not contain it. There we go. Oof, reversed it. Here we are with 14 out of 29 snapper packages right here. Are the conditions for creating the interval met? Well, if there's 14 that have them, how many would not have them? If there's 14 that have them, how many would not have them? I know I'm speed running these, but if there's 14 out of 29 that have them, then how many would not have them? We're taking a random sample here, which is less than 10% of the total snapper packages. If 14 out of the 29 have them, how many did not have them? 14 out of 29 have them, 15 don't have them, and both of those are greater than or equal to 10, so we have at least 10 successes, at least 10 failures, success-failure condition. Construct a 95% confidence interval. Well, we gotta do more math right here. 14 divided by 29 is going to be p hat. 1 minus p hat is q hat. P hat times q hat over n right there, square root. And then the z-score is, once again, 1.96. There is the margin of error. And now we got to add these. So 14 divided by 29 plus the margin of error. And that's going to be point. Same type of question we just did earlier. And then 14 divided by 29, which is p hat minus. And there it is right there. That's going to round here to that right there. And check the answer. We are good to go. One is 95% confident the true proportion of all red snappers sold in these restaurants in these states is not actually red snapper. One is 90% of all red snappers from the study. That says the study at the end. And now we're changing to percents because my Pearson likes to mess with you. There I am, 95% confident the true proportion of things that aren't red snapper is contained in the interval. And I think this went back to the problem we've already done, so it's going to mark that I didn't do it. Oops, I'm going to lose those. No, I wanted to see the beautiful completed. If you can't tell, are these problems pretty repetitive on what you have to do to know how to take p hat and find from p hat times q hat over n square root. Standard error has been found. 95% confidence, 1.96 z-score, margin error has been found. And from here, we take the estimate of p hat, add to it this, and get 53.8, which is the upper interval. Do these problems look repetitive? What do you think? What do you think, Cameron? Do these problems look very repetitive to where you're basically doing the same formulas and same interpretations? I am 95% confident the true proportion of Californians who consider moving out of state. No, not from a random sample, the true proportion. I am 95% confident the true proportion of Californians who think they might move out of state is contained in the roll blank to blank. There we go. Got that one. Since the confidence roll does not contain 50%, is greater than they should. If it is, I think if it's higher, they're gonna. If it can be reasonably sure that more than, yeah. So they think it's more than that, so they should invest. Which of these statements correctly interprets 95% confidence roll? 95% of the samples will produce a confidence roll that captures the true proportion. 95% of the time, the sample proportion will be in the interval, not the sample proportion, the truth. 95% of the sample is in, no. I don't even like that second one, but it's closest we get to a good interpretation. If the confidence level increases, the interval will do what? This is on our test usually too. If the confidence level increases, what happens to the interval? 68, 95, 99.7. If the confidence level increases, the interval will do what? It gets wider. But here's the thing also, it gets less precise. So, and that's correct, Cameron, right there. So it's not going to go into that detail for you, but less precise means you have a wider interval. To increase precision, you can make a larger sample size, which will lower your uncertainty by decreasing the standard error. So it's going to get wider when you get more confident. That right there's got that. We got right here, that's a huge sample size. It's random. That looks good as far as I can tell. Yeah. The margin of error is this, 95. Would the margin of error be larger or smaller? It's going to be smaller. To be more confident, the interval for the true proportion would need to contain it more often. So it would be larger margin of error. That's all they're asking right there. For given sample size, higher confidence means a smaller margin of error. No, it's reverse. Higher confidence means a larger margin of error. For a specified confidence level, larger samples provide smaller margin of errors. Oh, these are, I need to go into more detail on these because I need to map these out. I usually do that. This is tricky. For a specified, like if you keep confidence the same, larger samples, yes. For a specified confidence level, larger samples provide smaller margins of errors. That's true. For a fixed margin of error, that means if you fix the margin of error, increasing the sample provides greater confidence. Yes, because they counterbalance each other. That's, someone just got the answer for free on these. For a given confidence level, having the margin of error requires twice the sample size. I'm going to end with this one because I really like this one. So in truth, if you look at this, we'll end with this. I think it's really cool. I always like showing this one and how it works. So it says right here, if you want to have the margin of error, just take twice the sample size. But here's the thing. Why can we not just multiply this by 1/2 and get 2n? Why can't you just multiply this right here and get 2n right here? Why can't you just do that? To get half the margin of error, just multiply this quantity right here by 1/2, it's underneath a square root. So what we need to do is we need to put something that would be 2, but it would be 2 because it's been square rooted. So we'd go right here and do 1/4. And the square root of 1/4 is 1/2. Just think about it. You can break up the radical if you want and do it this way, and it turns into this, and then you can just throw the radicals back on. So we don't need double the sample size to do this. To get half the margin of error, you don't need double the sample size. You need what times the sample size? To get half the margin of error, to make your margin of error half the size of your margin of error to make it half as small, you don't need double the sample size. You actually need what? So you wouldn't need to double your sample to get half the margin of error that you found. You're like, oh, my interval's too wide. I want half of that margin of error. You wouldn't double it. Mathematically, you have to do what? You wouldn't just double it to get 1/2 the margin of error. You'd have to get 4 times. What about if you wanted 1/3? Like if you wanted your margin of error to be, you'd have to quadruple it. You have to get 4 times your sample. What about if you wanted your margin of error to be 1/3 of what it is? If you wanted your margin of error to be 1/3 of what it is, your sample size would be how many times bigger? You're like, oh, I want my margin of error to be 9 times, because then you put right here 9, and that's what it'd be. So if you notice, there's exponential growth. Like to make your interval much smaller, you have to exponentially increase your size of your sample. So there's diminishing return on large samples, because after you get to a certain point, you really don't get that much smaller of intervals. And it's like, well, we took a sample size of 1,000. We could do 9,000 though and get 1/3 of the margin of error. And it's like, we don't got time or money for that. So this one is false. I do like showing these more than I've done right here. This is false. It would take quadruple the sample size, not double. That's false right there. Oh, what's this one say? A student is considered publishing a new magazine aimed directly at owners of Japanese automobiles. He wants to estimate the true proportion or fraction of cars in the United States. So I am 94% confident the true proportion of Japanese automobiles is Canadian interval. So you notice the true proportion of Japanese automobiles. We're trying to estimate that to see if it's in the interval. We are 95% confident. Yeah, sure. There's right there. If you know my interpretation, I'm not even joking. We'll end with this. Remember the interpretation I wrote? I am blank % confident that the true blank is contained in the interval blank to blank. And if you look at this, they're showing true proportion right there. P, the true proportion of Japanese automobiles. And then they have it, they're trying to see if it's contained in that interval, which there's the interval from the lower to the upper. And they've made it a little bit different order. I am 95% confident the true proportion of Japanese automobiles is contained in the interval blank to blank. There's the answer. So if you know how to do the interpretation, a lot of these questions for the remainder of the semester have these interpretations. And we just ran the whole rest of the problems. We'll probably do more on these, especially the quizzes. If you're working on the homework, you got a lot of helps and tips, but review. Remember the theory is what's important here. But until then, did anyone get 100 on the homework? I doubt anyone followed along with the ones where you have to do the math. But here's the thing. The math is the exact same for all of them. It's the same thing. Just find the numbers, plug them in. A lot of people get stuck on the z-score, though. With that, bye for now, everyone. Bye, Red Bull time.